Here's the 2017 common questions. Okay, so this is from a proper exam from 2017. And these are the questions that would be on the foundation paper, but they'd also be on the higher paper. So this is particularly good if you're new to higher papers, because this is stuff that really you need to be on top of if you're going to make a good fist at that, okay? It says here the maximum mark for this paper is 24, so there are 24 marks worth of material that is on the foundation and the higher, okay? Remember, if you just got this stuff right, that would probably be enough for a grade 5, okay? If you managed to get 24 marks, okay? Let's have a look at it. I've gone through the paper again, and the red things that I've written are what these questions are, so if you need any further practice, then this is what you're going to look up for revision, okay? We'll get into it. The first question I think is quite tricky, and they've been a bit over the top, I think, with what you have to do for this for 2 marks, but let's have a look. Write the number 6,005,200. For some reason, they've given you a bit of a strange number, okay, but we're going to start by writing that out in proper numbers. So 6 million, not 500,000, 5,000, okay? So 6,005,200. That's what we mean by that number. And we have to write it in this thing called standard form. So it's worth looking at some more standard form if you don't understand this, okay? But this is what we do. We take the first number, I'm going to write points, and then I'm going to write all the numbers out until I just have repeated zeros, okay? So what I mean by that is I'm going to write these numbers here, and I'm going to stop, because after that is just repeated zeros. So I get 6.0052, okay? That's how you start off these questions. Times 10, this is how standard form works, to the power of, I'll use a different colour. The power is how many numbers are after the first number. So I've got 1, 2, 3, 4, 5, 6. So it's 6.0052 times 10 to the power 6, okay? This power 6 is telling you that it's a million. I know it's 6 million, so I know the power is going to be 6, okay? That's how standard form works, okay? It's definitely worth spending a bit of time looking at some revision questions on standard form if you don't understand that, okay? Let's have a look at question 2, which is, again, a really nasty one. I promise you there are plenty of questions in this that you can get stuck into, but I'm not a massive fan of this question. Let's just have a look at it. So, x kilometers per hour equals y miles per hour, and it gives you underneath that x kilometers per hour is equal to 8 kilometers per hour is equal to 5 miles per hour. Write a formula for y in terms of x, okay? This is nasty, this question. Let's have a look at what we have to do. Here's what I'm going to start by doing. I'm looking at these two numbers, 8 and 5, and I'm thinking, how do I make the number on the left equal the number on the right, okay? Or is there a way that I can make these two numbers the same? And I'm going to do that by timesing, okay? So I'm thinking, what number is in the 8 times table and in the 5 times table? And if you need to write them out, so 8, 16, 24, 32, 40, that's going to be in the 5s, isn't it? 5, 10, 15, 20, 25, 35, 40. So I want to make both of these numbers 40. How do I do that? Well, I'm going to times this thing by 5 and this thing by 8, okay? So if you look, I've basically just swapped the numbers over. Now, that's what we need to do to this original strange little formula that it gave us, okay? So what I'm going to do is I know these are the same if I times this thing by 5 and this thing by 8. So I'm going to write that. I'm going to times x by 5 to get 5x. And I know that will equal y times 8, which is 8y. Okay? Find a formula for y in terms of x. What that means is I need my answer to be x equals something. Okay, so this one I'm going to write straight in my answer box. X equals, what do I do if I want to get x on its own? I need to divide by 5 both sides, okay? Because 5x will become x, so I'm going to get 8y over 5. That is a really nasty question, I think, for 2 marks, especially for it to be so early on, okay? But there you go, that's what we do for that one, Okay, another possible answer if you do was this. 8 divided by 5 is 1.6, so I could have had 1.6y is another way to do it, okay? But that's probably what I'd write, is just that strange fraction there. Okay, let's move on. The next question's quite nice. We can get stuck into this one, okay? So it's all to do with circle area. Remember, this whole paper is non-calculator, okay? So I need to know the formula pi r squared. I know that's going to come up somewhere, but I can't use a formula. If anything, that makes things easier for me. I'll show you why in a bit, okay? Right, let's read the question. The area of the square is 64. Work out the area of the circle inside it and give your answer in terms of pi, okay? Right, I've got a square that has an area of 64. So how do you work out the area of a square? If you want to think of it as length times width, okay? But remember that the length and the width have to be the same, okay? So what side, if I times it by itself, just looking at the square, would give me 64. So what I'm actually trying to do here is the square root of 64, which I know is 8, okay? So if those sides were 8, then the square would have a area of 64 centimeters squared, okay? So that's how big each, the length and the width, so the base and the height, or whatever you want to think of it are, okay? So there you go, that's got you 1 mark just for writing that, okay? Let's have a look. So if I know that this length from here to here is 8, okay? I know that this length from here to here is also 8. And what I've drawn there is the diameter of a circle, okay? So I've got this circle there, and I know that its diameter is equal to 8 centimeters, okay? My formula, if you look at it here, pi r squared doesn't have diameter in it, it has radius, okay? Remember, radius is just halfway across, so the radius would be 4 centimeters, okay? So I'm going to use that in my formula. What I've got is pi times pi, so this is the area of the circle, it's pi times the radius, which I'm just worked out as 4 squared, okay? What is 4 squared? It's 16. So it's 16 times pi, or 16 pi, and that is your answer straight away. Okay, that's all we need to do. Circle questions are actually easier in non-calculator, if anything, because you don't have to mess on with decimal places and that sort of thing. Okay, so that is your answer. So let's just recap really quickly. Diameter was 8. Okay, so the radius halfway across was 4. So it's pi times 4 squared, okay, which is 16 pi, and then we're done. Okay, let's move on. Right, this one should be straightforward, okay? These are the sort of ones, 5 marks is a lot of marks. You need to sort of be able to get full marks on this one, really. It's just about percentages and a bit of money work, okay? Let's read it. Billy wants to buy these tickets for a show. I know that 4 adult tickets at £15 each and 2 child tickets at £10 each, okay? Right, read this bit really carefully. 10% booking fee is added to the ticket price. 3% is then added afterwards. Okay, so let's get on to what we can actually work out. Let's start with adult tickets. I'm buying 4 of them at £15 each. So let's do 4 times 15. Okay, double it and double it again. Okay, and you get £60 is what the adult tickets cost. Child tickets. 2 of them at £10 each. I can work that one out. 2 times 10 is 20. Okay, so this person, Billy has spent in total £80 on tickets. Okay. Right, we've got plenty of marks, probably got 2 marks for doing that, which, I mean, that is really straightforward. Okay, so we spent £80, then we get onto the percent thing. So a 10% booking fee is added to the ticket price. So I need to do 80% add 10% of whatever that is, okay? So I'm going to do £80 add, what's 10% of £80? It's £8. Okay, so I add those things. So I've got £88. Okay, so that's this bit dealt with, finished that, okay? Then we're just moving on to the bottom bit. 3% is then added for paying by credit card, and this guy is paying by credit card, okay? So I need to do £88 add 3% of 88. Okay, so that's going to be slightly hard maybe. Let's have a look. What's 1%? So to work out 1%, I need to divide 88 by 100, and that will give you 0.88. Okay, it's 88p is actually what it is. I want 3 of them because I want 3%, so I'm going to do 0.88. I'm just going to add these 3 things together, okay? 8, 16, 24, carry the 2, 8, 16, 24, add 2, so that gives you 26. So it's £2, run out of space, £2.64. That is not my answer. I'll leave a bit of space here, okay? So what did I have? I had £88, add 3%. So I need to do £88, add £2.64. I could probably do that in my head. Let's have a go. 88, add £2.64. Add 2, you get 90 quid, add 64. So it's £90 and 64 pence. That is the actual answer, that bit there. Okay, there you go. 5 marks there. Now, I mean, what's hard there? It's reading the question and doing 10%, then 3%, and not just doing 13% because it won't give you the same answer, okay? And then I think it's basically this bit's the only quite tricky bit, but there's nothing that bad really compared to some of the other questions we've already done. That should be a really straightforward 5 marks, okay? So have a look at that question really carefully. What we got up next? This one's a bit strange. They're only 1 mark each. Let's have a look. Remember, these are all on the foundation paper as well, okay? A mass of solid A is 6 times the mass of solid B. The volume is 3 times, okay? So what's happening with this formula, this density thing? I'm timesing the top by 6 because the mass is 6 times as big. And I'm timesing the volume by 3. So if you have a fraction where you've times the top by 6 and divided the bottom by 3, well, remember the middle of a fraction, 6 divided by 3, that's the same as timesing by 2, because 6 divided by 3 is 2, okay? So the density of solid A is 2 times the density of solid B, okay? So timesing by 6 and divided by 3 is the same as timesing by 2, okay? And then we're going to do the next one in a similar way. If the distance is halved, the distance has been times by 0.5, okay? And the time is doubled. This is a bit harder than the one above, but what is 0.5 divided by 2? It's the same as timesing by 0.25, okay? Now, which of these things is the same as timesing by 0.25? It's the same as timesing by 1/4, and that means you just quarter it, yeah? It's 1/4 of, so it means you divide it by 4. Okay, so that's what we get for that one. Bit of a strange question, but there you go. This is probably the most unpleasant of all of these questions. Let's have a look. Remember, I mean, it is a tick box at the end of the day, but let's have a look. Let's have a look at what this table means. So what this means is one person is in this gap somewhere between 20 and 0. Okay, this is how long people take to complete a task. So one person took somewhere between 0 and 20 minutes, okay? Remember, that means it can equal 20, but it can't equal 1. So it's bigger than 1, or it's less than or equal to 20 is what that thing means, okay? The next group means that 6 people were somewhere in the middle of 40 minutes and 20 minutes. So anything bigger than 20 or less than or equal to 40, they were in the second group, and there's 6 of them in there. And then 3 people are somewhere between 40 and 60 minutes, okay? So they could have maybe had 60 minutes, but anything less than that and upwards of 40, there's 3 people in that group, okay? Then we've got all these questions about what the mean and the range could be. The range are actually easier to work out than the mean, but we'll start with the mean, okay? Right, the mean could be less than 20. If we want a mean of 20, we're going to make all our numbers as small as possible, okay? So let's say this first guy in the top group took 1 minute, because then he'd be in that top group, okay? And let's make all the next ones as small as possible. Anything upwards of 20, so maybe these were all 21, okay? And 6 of them, annoyingly. 4, 5, 6, okay? And the next one I still want to be as small as possible, so maybe these next 3 people took, say, 41 minutes, okay? Okay, let's have a look at what this mean is. I'm not going to actually do any working out though, confusingly. Let's have a look. The mean of all these numbers is 21, because if you have just the same number over and over again, you get 21, okay? Now this 1 is going to bring things down a little bit, and this 41 is going to bring things up more than the 1 did, okay? So I know that there's no way that the mean's getting brought down below 21, okay? It's going to be bigger than 21 somewhere, okay? But there's no way that I'm having a mean less than 20. Okay, so that's first one is false. Let's look at the next one. For the next one, I'm going to make things as big as possible. So maybe the first person is 20. Maybe all of the rest are 40. 3, 4, 5, 6. Okay, and then the last 3, maybe they're the biggest they can be, which is 60. Okay, so if that was the case, the mean of all these numbers is 40. Okay, this would drag it down a little bit, but then these are going to do more work because there's 3 of them that are going to drag it up. So it's definitely possible that the mean could be more than 40. I'm not going to even bother working it out, but if I did, I know that the mean would end up being bigger than 40 because the 60s are going to drag it up a bit. Okay, so it's definitely going to be more than 40. They're going to drag it up more than the 20 is going to drag it down. Okay, the mean could be less than 40. So this one, I don't need to draw anything again. I'm just going to look back at this ones when everything was small again. The mean of those numbers is going to be less than 40 because the mean of those 6 in the middle is 21. They're going to get dragged up a little bit by the 41, but dragged a little bit down by the 1, but I know it's going to be less than 40, whatever it gets. So that's going to be right. Then we move on to the range, okay? The range could be more than 40. What's the biggest range we could have? Well, the biggest number in our list would be 60, if that's as big as possible. And the smallest number in our list is something like 1, okay? So if I did 60 minus 1, that'd be 59. So I could have a range bigger than 40, okay? The range could be less than 40. So what is, I'm going to have to run out of highlighters here. What's the smallest this could be? Because I want a small number, take a big number, basically, okay? So the smallest on the top would be 41, say. Take away the biggest, the bottom one could be 20. 41 take away 20 is 21. Okay, so the range could definitely be less than 40. The range could be more than 60. I've already worked out the biggest range I possibly could. And the biggest range I think you can get is 59. So no, you can't get that. That's a really nasty question, that, okay? If you want to spend a bit of time, it is non-calculator. You could try adding up some of these things, doing some sort of estimates or something to try and work out roughly what the mean is, if that helps you, okay? But again, not a big fan of that question. Let's move on, okay? You need to get all 4 marks, you needed everything right. I think to get 1 mark, you needed 2 right. So it's probably likely you'll get a couple of marks in if you just guessed, to be honest, on that one. But anyway, let's carry on. Right, 7 is probably the most important question on this whole paper because this will definitely 100% come up on one of your papers, okay? And it's quite straightforward. Products of prime factors, whenever you see that, we start by doing what we call a factor tree. Okay, so like I say, this is guaranteed to come up and it's an easy 3 marks, especially if you look at the last question, which is only 4 marks, okay? Here we go. I need 2 numbers that times to get 36. I'm not allowed to use the number 1 ever when you do these, okay? Because 1 isn't prime. We'll come on to that in a bit. 2 numbers that times to get 36. I'm going to go for 2 times 18, okay? 2 is a prime number because I can't carry on doing this tree by splitting it up into 2 numbers without using the number 1. Okay, so remember, I'm not allowed to use the number 1 doing this. Okay, so 2 is a dead end, so I put a ring around it. Let's split 18 up. That is 2 times 9. 2 is a dead end, it's a prime number. And 9 isn't, but people get confused. 9 isn't because it's 3 times 3. Now 3, I can't split up anymore because 3 is a prime number, so I'm finished. Okay, I've got all dead ends at the end of my tree. This is called a factor tree. I don't actually get any marks for doing what I've done there. This is what you have to write, so you need to remember this. Product means times, and prime factors are the circle things. So this is saying times the circle things together, things we've circled in this little tree, okay? So I'll write this 36 equals, you don't actually need to write 36 equals, just write the next bit if you want. 2 times 3 times 3, okay? That is what product of prime factors means. These are all prime factors, circle things and I times them all together because product means times, okay? The last bit to get a final mark is this. It says in index form, and index means powers. So instead of writing 2 squared, 2 times 2, I write 2 squared. So 3 times 3, I write 3 squared. That is just finished. Okay, that is your answer. There's nothing hard there at all. You need to learn how to do this thing called product of prime factors, okay, because it will definitely come up. It'll just give you a different number, and you have to do it from that, okay? So have a practice of them, okay? The last one, simultaneous equations. There was a simultaneous equations on the last paper I went through as well. This one's slightly different. With simultaneous equations, you want to get rid of either the x's or the y's by doing something, okay? Let's have a look at this. Here I've got plus y, and here I've got minus y. Okay, let's imagine these were a number. What if you had, say, plus 10, and you had minus 10? Okay, what would you do with those two numbers if you wanted to get rid of them? What do you do to 10 to get rid of it, okay, to make it equal to 0? If I do 10 add minus 10, it gives you 0, okay? 10 add minus 10, or think of it the other way around, minus 10 add 10 gives you 0. Either way around you do it, it disappears. And that's what I want to happen with simultaneous equations, okay? So here's what I'm going to do. I'm going to take these two things and I'm going to add the whole bottom line to the whole top line. So what is 2x add x? It's 3x, okay? What is plus y add minus y? The same as with plus 10 and minus 10, or plus 6 and minus 6, or whatever you want to think. They disappear, so it's just going to vanish, okay? So 3x, no y's, and that was the point of doing this, equals 18 and 6 is 24, okay? So all I've done is added those two top rows, the top row to the bottom row, and the y's have vanished because you get nothing if you do minus y add y, okay? 3x is 24. 3 times something is 24, so I'm going to divide both sides by 3, okay? That's what I'm doing. So x equals, how many 3's go into 24? 8, okay? So I've got part of my answer, x equals 8. Okay? Right, we're almost done. Let's have a look at this second one here. I'm going to rewrite it here on the right-hand side. X take away y equals 6. I know what x is though, because I know that x equals 8, okay? So I know that 8 take away y has to equal 6. So 8 take away what will give you 6, okay, is what you need to think. So I know that y has to equal 2. So that's your answer finished, okay? So that's how you do simultaneous equations. There's a nice way to check as well. Let's have a look at the first equation. Okay, you don't need to do this. We're going to do in orange down here. So the first equation said 2x add y equals 18. So let's check using our numbers, okay? So 2 times 8 plus y, which is 2, which is 16 add 2, which does in fact equal 18. So I know I've got it right, so I've used the other one to check, okay? That's simultaneous equations, okay? So have a look through the questions we've done. Look at the red thing. If you don't have a copy of this, email me, but to be honest, you could probably just pause and carry on, have a go through them, okay?